Lesson 8.4.13, All, Some, or None, Part 2, Systems of Equations with one, many, or no solutions. In this lesson, we'll determine whether a system of equations has no solutions, one solution, or infinitely many solutions. All right, we're on page 195 in your workbook. And like I said a moment ago, in this lesson, we're going to determine whether a system of equations has one solution, no solutions, or infinitely many solutions. So one solution, no solutions. I'm lining them up with the with the pictures down here. Or in this third example, we're going to see infinitely many. Solutions. The x and y values that make both equations true are known as the solutions to a system. We've done enough of that solving to know what a solution looks like. But depending on the equations, a system can have one solution, no solutions, or infinitely many solutions. Oops, probably didn't need to write solutions again. So let's take a look at what both the graphs and the equations of each of these situations would look like. Let's start with this graph. I can see a system of equations. It's two or more equations in the same variables. And first thing I see here is this equation that has a slope of 2 and a y-intercept here at -2. I could rise 2 and run 1 if I wanted to make this line, but it's already made for me here. And then I have this equation where the slope is -1/2 and the y-intercept is 3. So I could go down 1 to the right 2 to make this line if it weren't already made for me. Oops. We started this part of the unit in talking about systems of equations by looking at where those two lines intersected. And if the two lines in a system intersect at a point, then there's one solution. And I would be able to tell just from the equations, even if this graph weren't here, I'd be able to tell from these slopes that there was going to be one solution. And what I notice is if the two lines have different slopes, they're going to intersect somewhere. There's going to be one solution. Let's take a look at this example. In this case, my first equation has a slope of 2/3 and a y-intercept of -2. That must be this one, since the y-intercept is -2. And in my second equation, the slope is 2/3 and the y-intercept is 3. That must be this one, because the y-intercept is 3. And what you probably notice is that in both of them, the slope is up 2 and to the right 3, up 2 and to the right 3, up 2 and to the right 3. And these lines are never going to intersect because they have the same slope. And I could tell that just from looking at these two equations. If the slopes are the same, they're never going to meet. If the two lines of a system do not intersect at a point, there are no solutions. And that happens when the two lines have the same slope. And different y-intercepts. That's important. Same slope, different y-intercepts. Different y-intercepts means that they're different lines. They just happen to have the same slope. And finally, we have these two equations. We have y equals 1.5x minus 2. Well, it must be this one because it's the only one there. And this equation, which is y equals 3/2 x minus 2. Well, 3/2 is just another way of saying 1.5 or 1.5. So these two lines, or these two equations, have the same slope and the same y-intercept. So they're really the same line just laid on top of itself. So if the two equations have the same slope, like these do, oops, both of them are 1.5, just written different ways, and the same y-intercept, -2, then the system has infinitely many solutions. Remember, the solution to a system are the x and y values that make both equations true. And every point on these lines is a solution to each equation, so there's infinitely many. So how can you tell from the structure of the equations if a system has no solution, one solutions, or infinitely many solutions? Well, we've already kind of summarized it up there, but let's just focus in on those slopes and y-intercepts. No solution means they have the same slope, different y-intercepts, they're parallel lines. One solution means they have different slopes. As soon as they have different slopes, you know there's a solution. And infinitely many solutions, ultimately they have the same slope and the same y-intercept, because they're the same line, really. And that's how we do it. So systems of equations can have one solution if the two lines intersect, no solutions if the two lines are parallel, and infinitely many solutions if the two lines are really exactly the same line.